Welcome to Pre-Calculus. Today we want to begin looking at section 1.9, the distance and midpoint formulas, circle. Our first attack here will be the distance formula. If we have 2 points here, point 1 and point 2, along a Cartesian coordinate system, we can actually use Pythagorean theorem to calculate the distance formula here. And if we plug it in to Pythagorean theorem, we know that c squared is equal to a squared plus b squared, or you may see it as r squared is equal to x squared plus y squared. Just depends. Here we actually take the absolute value of the distance to alleviate a negative distance, but in this particular case here we'll square it. So if we take Pythagorean theorem and solve for d, and we're going to end up with a positive value here, so we end up with this distance formula right here. And that would give us the hypotenuse, or the distance of that particular line. So the distance formula is between 2 points in a rectangular coordinate system. And here's your particular formula here for the distance formula. And to compute the distance, we find the square of the difference there. So if we have 2 points, this will be P1, which is x1 and y1, P2, which would be x2, y2. We put them in this formula here, and we come out with an exact or an approximate value. And that's the length of that particular line. So let's look at this example. We plug it into our distance formula is equal to the square root, and we have x2 minus x1, and we want to square that, plus y2 minus y1, and we want to square that, and we end up with the square root of 34, or approximately 5.8, the distance of that particular line there. We can also find the midpoint of that line as it relates to a coordinate by using the midpoint formula. And the midpoint formula, we take the average of the two values. So we take the average of the x coordinates and we take the average of the y coordinates, and it becomes the actual coordinate to find the midpoint. So here we have again P1, P2, we actually add the x values and then divide by 2, we get 5 halves. We add the y values and divide by 2, we get 13 halves. And that will be the coordinate location for the midpoint of that particular line. So let's take a look at this example here. It's actually a coordinate, and we take x1 plus y1, or x2 divided by 2, and this would be y1 plus y2 divided by 2. And here we have -3 and we have 8. So that particular coordinate there will be -3 eighths there. And let's take a look at a circle. And here, if we define a circle, we have the set of all points in a plane that are equidistant from a fixed point, and that's called a circle. And we define that circle with a center HK, and the distance from the center to any point on the circle is called the radius. And the standard form for a circle of an equation is this particular form here, where h and k is defined as the center and r is defined as the radius. We can also use the TI to graph a particular circle. Just remember, if you're actually using the TI and we want to graph it, and I'll bring up some demonstrations later on, but if we want to graph it, we always want to solve it in terms of y, and we'll have two formulas here, y1 and then we have y2, and we can do a zoom square and we'll end up with this particular circle here. You may find just a little bit of gap there. That's just the graphics of the calculator, but it is a circle. We want to write the standard form given this equation here, and we have a -4, and what I like to do, this is our h and this would be our k. I like to go ahead and put -4 in. We'll put +1 and 3, and then here we end up with negative times a negative, it gives us a positive, and we actually have a negative there, and then we have 9 there. So that would be the standard form for that particular equation. Now find the center of the circle, whose equation, they give us the equation, they want us to graph it, then they want us to use the graph to identify The relation is domain and range, and then y is a relation and not a function. So if we look here, we know that the center is going to be the opposite sign of what the h value is. So it's negative. This would be hk. So it's going to be negative 3, 4. And the radius will be the square root of 9, which would be 3. In this case here, the domain, if we look along the x-axis, we're starting at negative 3. The radius would be 3, so we can count over 1, 2, 3, and we end up with 6, and it includes 6, and we go to the right 3, and we end up with 0. And then on the range, we move down, we're at 1, we move across, we're at 7. So why is this a relation and not a function? And it's not a function because it's not one-to-one. We can perform the horizontal test, and we see that the graph touches that line in more than 2 places. Or we can do the vertical line test as well. Write the standard form here. So we have a point and the radius. So we have x minus a negative 2 quantity squared plus y minus 7 quantity squared is equal to 5 squared. So this would be x plus 2 squared plus y minus 7 squared is equal to 25. So that would be the equation in standard form for that particular line there. Here we want to find the center of the graph, and we want to graph it here, the center. And I'll just abbreviate. The center is going to be 6 and negative 5, and then the radius r is equal to 7. So if we actually locate the center, we go over 6 and come down 5, and it looks like 1, 2, 3, 4, 5. It's hard to see my numbers there. And we'll put a circle. I'm not for certain I can draw a circle, but I'll try. That has a radius of 7. So 1, 2, 3, 4, 5, 6, 7. So somewhere right in there. So we can actually take a look at the domain. Let me move this over just a little bit. Yep, there we go. And we can take a look here, and we can actually look, and we get the domain from these values here, and we'll see that the domain is, it includes negative 1, and we can actually add 7 to 6, which would be 13. And then the range, we can get the range from this value here and this value here. So the range would be, we actually subtract negative 7 from negative 5, which would be negative 12, and it goes up to, looks like 2, and it includes 2 there. So that would be the range and the domain there. We also have a general form of the equation of a circle. Depending on which form it ends or end up in will determine how we determine the standard form of a circle, where D, E, and F are real numbers. So if we're given the standard form and we want to write it in the general form, we actually do what we call, we can complete the square. In this particular case here, we'll expand this factor and this factor here, collect like terms, and we'll write it in this particular form here, and that's the general form of a circle. So here we want to complete from the general form, we want to go to the standard form, and we have to complete the square. This is something that you've done in algebra, so you should, if you've taken algebra, you should be able to complete the square. If not, what you do here is you actually take half of this value and you square it. That's where the 49 came from. This is actually going to be plus 7 squared. You take half of this value and square it, so this will be plus 4 squared there. And that's going to be 49 and 16, and you do it on one side, you have to do it on the other side. So we add it to both sides, and then we end up factoring this expression here and factoring that expression, and we can take the square root of 36, so we can find our center and our radius there. So this particular example here, we want to group our terms. So we have x squared minus 4x plus y squared plus 12y, and we're going to subtract 15 from both sides. And now I'm going to complete the square for the x term. I have x squared minus 4x. I take half of 4 and square it, so that would be plus 4. And then plus y squared plus 12y. I take half of 12 and square it, so that's going to be 36. This is going to be equal to, and that will be negative 15 plus 4 plus 36. So I'm going to factor this. This is going to be x minus 2 quantity squared plus y plus 6 quantity squared is equal to, and this will be 25, and this can be rewritten in terms of a square, so that'd be 5 squared. So based on that, our center is going to be 2 and negative 6, and our radius is going to equal 5. So we should be able to graph that. Let's take a look at this example. We want to group our x terms. X squared plus 6x plus y squared minus 8y is equal to 0. So we're going to complete the square here. X squared plus 6x. We're going to take half of 6, which is 3, and square it, plus 9, plus y squared minus 8y. So we'll take half of 8, which will be 4, and square it, be 16. And we're going to add that to both sides. So we have 0 plus 9 plus 16. So we'll factor here. This will be 8x plus 3 quantity squared, and this is going to be y minus 4 quantity squared, and this will be 25, or it'll be 5 squared. And so our center is going to equal negative 3 and 4, and our radius will equal 5. Here we want to find the distance between 2 points, so we put it in the distance formula. So we subtract our x terms. So we'll have x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and we end up with the square root of 109. So that's the exact value there. Here we want to find the midpoint of a line, so we add up our x coordinates. So we have negative 1 plus negative 5, and we take half of that. We add our y coordinates, negative 1 plus 8, and we take half of that. And we end up with negative 3 and 7/2 as the midpoint of that particular line segment. And then our last one here will be writing the equation of